So, here's where things get interesting. NASA just released a fresh Hubble shot of 3I Atlas, and it instantly resets the baseline for what this object is doing right now. This isn't a stacked composite or a long process mosaic. It's a direct F350LP capture from WFC3. Basically, the cleanest look we can get at the inner structure. And the first thing that jumps out is how sharp the core appears, even after the brightening, even after the dust expansion. The center is still a tight concentrated point, no elongation, no splitting signatures, nothing drifting off axis. If there were any internal fractures, this is exactly the kind of image that would expose them. Then your eye moves outward and the scale becomes obvious. NASA marks the frame with a 30 Rsec reference, which translates to over 40,000 kilometers. And that entire region is filled with a smooth symmetric glow. No jets cutting through it. No obvious directional plume. Just a massive uniform cloud expanding evenly around the core. Here's the thing. For an object coming off perihelion, where thermal stress usually pushes things toward chaos, this level of stability is unexpected. Hubble isn't showing cracks or sudden asymmetries. It's showing an object holding together far better than models were predicting. That's why this image matters. It's calm at the center while everything around it keeps growing. Now, here's where the story flips. While Hubble shows a calm, tightly held core, ESA's JUICE probe catches something completely different, and it's happening farther out in the surrounding material. JUICE isn't using a science imager here. This is a navigation camera built for guidance, not research. Even so, the frame picks up to distinct features that don't match the clean symmetry we saw from Hubble. The first is a narrow, faint streak rising away from the main glow. That's plasma being pushed directly by the solar wind. It's thin, directional, and it doesn't curve the way dust usually does. In other words, this is a live interaction, not leftover debris. Below it, there's a second structure, broader, heavier, and angled differently. That's the potential dust component. It's slower, more diffuse, and not aligned with the plasma feature at all. Anytime you see details separating like this, it means the object is putting out fresh material. The key detail is how close ESA's camera caught this. JUICE wasn't expecting to see activity at this range, yet the structure jumps out even. In a star-dense background, the alignment, the angle split, the texture, all of it points to ongoing outflow that simply doesn't show up in the Hubble frame, because Hubble is zoomed tight on the inner region. So now you have the spacecraft telling the same story from different angles. One sees stability, the other sees motion. Now let's dig deeper, because when you take that same Hubble exposure and run it through different enhancement filters, the calm exterior suddenly looks a lot more complicated. The left panel is the untouched 7:172 exposure, the clean version you'd expect from Hubble. Smooth, bright, nothing dramatic. But the moment you switch to the center panel, the Unsharp Mask, the symmetry breaks. The inner region isn't a perfect circle. There's a tilt, a distortion, and a suggestion of uneven outflow that wasn't obvious in the raw frame. Then you slide over to the right panel, and this is where the entire story shifts. This is a Larson Sekanina filter, which is designed to catch rotational gradients in the inner coma, and suddenly you're staring at two distinct jets shooting off the core. One flares toward the sunward direction while the other pushes back, forming a clean anti-tail. And here's the part that matters. Anti-tails aren't common. You don't usually see this kind of geometry unless an object is spinning and releasing material in a very specific pattern. The filter essentially exposes the underlying engine, whatever is driving the activity inside. It's subtle in the raw image, invisible to casual viewers. But once enhanced, the structure jumps out to jets opposite directions and a spine straight anti-tail pointing exactly where you wouldn't expect dust to align unless the rotation is locked in and stable. That ties back to the ESA view, the plasma and dust tails splitting at different angles, to different data sets, to different instruments, and they're both pointing toward the same conclusion. This object is active, directional, and rotating in a way that's not easy to classify. So, that's where things stand right now. Hubble shows a stable, concentrated core. JUICE catches fresh activity in the outer material and the processed Hubble. Frames reveal jets and an anti-tail that shouldn't be this clean unless the rotation is locked in. 3 different views, one story. This object isn't quieting down. It's evolving. Now, I want to hear what you think. Do these new structures point to a simple rotational pattern? Or is there something else happening in the inner region that we're only starting to catch? Drop your thoughts below. I read every comment. And if you want these updates the moment the data drops, hit subscribe, tap the like button, and share this with someone who's been following 3i Atlas as closely as you. More images are coming, and I'll break them down as soon as they land. Stay curious, and I'll see you in the next.